Let's take a look at how to graph a parabola in standard form by hand. I'm also going to show you how to graph this using your graphing calculator, so if you want to see that part, just go ahead and skip to the end of this video where I get to that. Alright, so to graph this by hand, the first thing I'm going to want to find is the location of the vertex of this parabola. And to do that in standard form, I'm going to start with this equation. X is equal to the opposite of b over 2 times a. That's going to get me the x coordinate of my vertex, and we'll go about finding the y coordinate after that. So in your standard form equation, a is your coefficient of x squared, b is your coefficient of x, and c is your constant. So if I plug these values in, the opposite of b would be positive 8, since b is a negative 8. Divide that by 2 times my a value, which is also 2. That's 8 divided by 4, which gets me 2. So again, that's only the x coordinate of my vertex. I still need to find the y coordinate. However, that does tell me one more thing. That 2 actually tells me where the axis of symmetry is. So I'm going to go ahead and draw that dashed line on my graph. I know my parabola is going to be symmetrical about that line. So I'm actually going to label it 2, the axis of symmetry, and I'll probably label it with its equation as well, x equals 2. Don't forget to include that x in there so we know it's a vertical line. Alright, so now that I know my x value of the vertex, let's go ahead and plug that x value back into the equation and find the y value that matches up to. So again, I'm doing this all by hand. If you know how to use your table on your calculator to do that, that would be a good way to save some time. Otherwise, I'll just review some basics about order of operations as we go about evaluating this expression. So exponents come first, so I've got 2 squared, so that's going to be 2 times 4 minus 16, and then plus 6. And let's just go ahead and finish that out. So I get 8 minus 16 plus 6, which works out to be just a negative 2. So that actually is my y value of my vertex. So I'll plug that back in up here. I now have my complete vertex figured out, so I'll plot that point. And the way that I do these, I'm going to be looking for 5 points total to graph this parabola. So I have 1, I need 4 more to find. So to find your other points, we're going to kind of repeat this process over here of plugging in different x values. So let me set up an xy table. If you're clever with how you do this, though, you don't really need to find the additional 4 points. We only need to find 2 if we can use symmetry to find some points easily. So the way that I do this then is in my xy table, I'm going to put my vertex right in the center. So 2 and negative 2, I'm going to put that right in the center of my xy table. And then I'm going to pick 2 points that are below the vertex in the x column, and 2 points that are above it. And because this was symmetrical, and because my vertex was an integer, I know that the y values up here are just going to repeat down here. So that's how we can kind of save a little bit of time. So I'm going to plug in 0 for x and evaluate, and I'm not going to show all that work. If you need to do that work, go ahead and pause the video for yourself. But when I plug in 0, I end up with 6 for y, and when I plug in 1, I ended up with 0 for y. Again, if you want to try that yourself, go ahead and pause the video. Otherwise, I'll show you in a second how to get those values on your calculator anyway. So because I was symmetrical about the vertex, or because parabolas are symmetrical about the vertex, I know that those y values will just repeat there. So there's my 5 points. I really only need to find 3 of them. And then I can go and graph those 5 points to see what my parabola looks like. So 1, 0 is going to be right there, and then 3, 0. You can just use symmetry though. Oops. There we go. And then finally we've got 0, 6. There, and then just using some symmetry, I can reflect that point over there. Now that I have my 5 points, go ahead and make a smooth U-shaped curve. You don't want this to be too pointed down at the vertex, so make it as round as possible. Add some arrows because that parabola will go on forever. So there is a lovely looking parabola graphed in standard form by hand. At this point, I'm going to switch over and show you how to do the same problem using your graphing calculator to find the minimum value or the maximum value, and to find all those points as well. So we've just graphed this parabola by hand in standard form. Let's go ahead and take a look at how the calculator can be used to do the same thing. So start by going into y equals and get your equation typed in there. So let's type in 2x squared minus 8x and then plus 6. And if I were to hit graph right away, I could see what it looks like. I see that it matches up to what we drew by hand. There it goes, very slowly. And so yeah, that looks like what we did, but let's go ahead and be a little more accurate with this. So the first thing I want to do is actually want to find the vertex. Just like we found the vertex by hand, I want to find the vertex using the calculator first. So to do that, go into our trace menu. So hit second and trace again to calculate. And none of our features say vertex, but we do see min or max. And we've been talking about how the vertex represents either a minimum or a maximum value. So you do have to select the right one. So take a look at your parabola. And because it opens upwards, I can see that my vertex would represent a minimum value. So select option 3, minimum. And if it is a max, you have to select max. So they're going to ask you 3 questions down here. They'll say left bound, right bound, and guess. Basically what that means is move your cursor so you're a little bit to the left of the vertex. Now you don't have to get too close to it. Like I probably wouldn't want to be there because I don't want to accidentally miss it. So just move somewhere to the left of it. I can see that over there my vertex is my cursor is clearly to the left of the vertex. So press enter. It'll ask you then for the right bound. So again, move your cursor so you're a little bit to the right. Don't get too close, you might miss it. So be a little bit to the right and press enter. You should have seen these 2 triangles pop up. They should be facing each other with the vertex trapped in between them. If they're facing away from each other, then you've done it backwards. So go back and fix that. For guess, just hit enter a 3rd time. And your minimum value will pop up. Now, some of you may have gotten different values down here. Some of you may have got x equals exactly 2 and y is negative 2, which is our vertex. Some of you, like me, may have got 2 with all those zeros. Some of you may have gotten 1.99. Your calculator, for whatever reason, just can't quite get to that value itself, depending on where you put your bounds. So if you ever see all the zeros or all the 9s, go ahead and round appropriately to 2. Or whatever the number might be. Now be careful, don't always round, like your vertex could be a decimal. If it's 2.5, then it's 2.5. But if you see all the zeros or all the 9s, make sure you round. So there's my vertex, which we have now found using the calculator. Finally then, to get all these points, if you don't want to do them by hand, let's just use the table feature of our calculator. So hit second, graph to find your table. And you could find all, wow, I started in 58. Let's change that. If that happens to you, go to second window, it's your table set feature, and let's change. It says, what do you want your table to start at? Let's start from 0. It's a little bit easier for us to work with. And then that's what you want the table to skip by. We want to skip by 1s. You shouldn't have to do that, but for some reason mine was very, very different. Now go back to your table, and you should see your table of values. So there's the points that we found, 0, 6, 1, 0. We found those by hand. And you can see they're symmetrical about that vertex at negative 2, 2. And you can kind of scroll through this and find any points you want. I wouldn't pick these values. They'd be way off your graph. So try to pick points that are convenient to graph. But there's a bunch of points you can use to make your parabola.